quantum numbers, the shapes of atomic orbitals, tsaka electron configuration and the chemical bonds. I know sounds familiar sa inyo yung mga topics kasi again, review lang din ito sa basic concepts ng inorganic chemistry. Okay? So, let's start with the fundamentals of atomic theory. Now, when we talk about atomic theories, it will always revolve around the nature of all matter. Okay? Now, lahat po ng substances, lahat, walang exception, lahat ng substances, they will always contain a minute size particles. Ang tawag doon, atoms. Now, throughout centuries po, ang dami pong mga scientists, okay, na nag-develop ng mga revolutionary discoveries, mga theories, mga observations about atomic theory, which has helped grow our knowledge about that particular concept. Pero, until now, there are still more to find out. That is why ongoing pa rin yung mga researches about this topic, yung atomic theory. Pero ngayon, let's just look at the most influential or yung mga pinaka well-known na mga scientists who have contributed much to the who have contributed much sa discovery ng atomic theory. So kung naaalala niyo yung atomic theory, yung unang papasok talaga sa isip natin is si Democritus. Always siya on the first line. Okay? First siya sa timeline when it comes to atomic theory. Okay? Pero si Democritus, saan ba niya nakuha yung idea niya about atomic theory? He actually adopted the idea of his mentor Leucippus. Sa mentor niya nanggaling yung idea niya about matter. Sabi niya, according to Democritus, matter is composed of tiny, indivisible particles called atomos. So si Mr. Democritus po yung nag-coined ng term atomos. Again ha, sabi niya, indivisible particles daw yung atom. Cannot be divided. It is indestructible, kumbaga. Cannot be destroyed or created. Okay, that's according to Democritus. Now, next on this list, of course, yung pinaka-known na atomic theory of matter in the year 1808, that was si Mr. John Dalton. Okay, yung sa kanya naman, yung atomic theory niya, para sa kanya, yung atom daw, nire-relate niya sa isang billiard ball. So, sa kanya po yun nanggaling yung billiard ball model. So, kung iisipin natin yung bola na ginagamit for billiard na board game, 'di ba? It is a hard, indestructible na bola. So, doon niya nirelate yung atom. So, almost the same concept with Democritus. Kasi 'di ba sabi ni Democritus, indivisible. Parang indestructible yung atom. So, ganun lang din. Inadopt lang niya yung concept ni Democritus. Ano lang yung kaibahan nila ni John Dalton? Si John Dalton, okay, aside sa billiard ball model niya, okay, nagkapag-suggest din siya ng 4 na postulates under Dalton's atomic theory. So, I know familiar na kayo sa postulates under John Dalton's theory. Yung una, sabi niya, yung matter daw is composed of extremely small and indivisible particles of atoms. So, ito yung pinakaunang definition niya, di ba? Yung concept niya about atom. Again ha, matter is composed of extremely small and indivisible particles of matter. Isa to sa mga postulate. Pag sinabi kasing postulate, parang hypothesis siya, parang statement which is not proven to be true. Kasi wala masyadong sapat na evidence or mga proof. Okay, so postulates lang siya about matter. So yan yung una. Pangalawa, another postulate according to John Dalton, all atoms daw of the same given element are identical. So say for example, you have 3 atoms of the element hydrogen. Lahat po ng hydrogen daw at all aspects, they are all identical. And given dito na illustration, sodium. Okay? Kung gagamitan natin ng postulate na to, sabi niya, lahat ng atoms ng sodium na element, all identical in all aspects. So, yan yung isang postulate ni John Dalton. Another postulate naman niya, okay, sabi niya, he stated na yung atoms of different elements they can combine to form compound. Naalala yung definition ng compound? 'Di ba? Different atoms of an element, when they combine together, that is a compound. So, isa yan sa mga postulate din ni John Dalton. Atoms of different elements, they combine to form compound in a definite ratio of small whole numbers. Okay? So, say for example, example ha, yung magsusulat ako, if ever magsulat ako sa whiteboard, ipin nyo yung mukha ko dyan sa cellphone nyo or sa laptop nyo para mas maklaro ninyo ang akong gisulat sa whiteboard. Okay, example sa yung third niya na postulate. Example ha, we have carbon dioxide. Okay. Yung carbon dioxide na compound, di ba kung titingnan natin, it is made up of different elements. Element ng carbon, tsaka element ng oxygen. Okay? Now, itong carbon dioxide, kahit saan pa to galing, kahit sa Poland pa yan, sa Philippines, sa Canada, yung carbon dioxide will always be present, or it will always exist in a fixed ratio. So, hindi po mag-iiba yung formula ng isang compound kahit ano pa yung source niya. Okay, so fixed always yung ratio niya. Okay, and that is expressed in a small whole numbers. Okay, so pwede na ulit ibalik sa screen. Ayan. Then yung last na postulate ni John Dalton, during chemical reactions daw, okay, di ba chemical reaction, this is an example of a chemical change. During chemical reaction, yung atoms daw are either combined, united, or rearranged. Okay? So, hindi sila nade-destroy during the chemical reaction. So, take note ha. So, yun yung 4 na postulates ni John Dalton. However, yung 4 na yun na postulates, it has received a lot of invalidations from other researchers or from other scientists, in which sabi nila, yung some of the postulates ni Dalton, it has been proven wrong. Okay, sige, try natin tingnan ulit, try natin i-analyze ulit yung mga postulates ni John Dalton kung meron ba talagang false statement. Okay, kasi sa ibang scientists na prove nila na wrong yung statement, may mga postulates si John Dalton na proven wrong. Okay lang naman kasi postulate lang naman siya, di ba? Ni John Dalton. Hypothesis nga lang kasi wala masyadong evidence. Okay, so balik tayo sa first na postulate ni John Dalton. Sabi niya again, matter daw is composed of extremely small and indivisible particles of matter. I-highlight niyo yung indivisible. Sabi niya, indestructible. Hindi po nada-divide daw yung atoms. Okay. Now, do you think ngayon, this is still a true statement or already proven a wrong statement na? Okay. So, kung ang answer nyo sa mind nyo, false statement na siya, tama po yun. Take note. Itong unang postulate, unang statement ni John Dalton, sa postulate na niya, this is already proven wrong. Okay. Bakit? Bakit proven wrong na siya? Okay, take note po. Yung atoms po ngayon, yung atoms po, alam niyo po na yung atoms, di ba, meron na siyang subatomic particles. So, we can no longer consider atoms as indivisible kasi that is because of the existence ng subatomic particles. Naalala ba yung subatomic particles? Di ba, yung atom. Inside of that atom, di ba, divided siya into subatomic particles like the proton, naalala yung positively charged na particle ng atom, yung electron, yung negatively charged particles ng atom, tsaka yung neutron, yung neutral one. Okay? So again, yung matter, yung atom, hindi na po siya considered na indivisible particle. That is because of the existence of subatomic particles. So itong first statement na to, proven wrong na. Okay, proceed tayo sa second postulate ni John Dalton. Sabi niya, all atoms of the same element are identical. Okay. Itong statement na to is also a false statement na po. Okay? Bakit? Ipin nyo again yung mukha ko dyan sa, may isusulat ako sa whiteboard, ipin nyo again ha, para makita nyo yung sinusulat ko. Okay, bakit false statement na yung second postulate ni Mr. John Dalton? That is because of the existence of what we call isotopes. Naalala po ba yung isotopes? Yung isotopes po, ibig sabihin, atoms of the same element. Sige, take note nyo ha. Atoms of the same, sulat ko na lang, same yung element. So, ibig sabihin, same yung ano niya, elemental symbol. Okay? Another, basta isotopes, atoms of the same element with the same proton number. Naalala mo yung proton number? Small letter P, then plus. Okay? Same proton number. Yung proton number that is equivalent to the atomic number. Okay? Ano ba yung atomic number? Yan yung characteristic property ng any element. Ibig sabihin, kahit anong element pa yan, okay, meron silang characteristic na atomic number. Paano namin malalaman, ma'am, yung atomic number? Makikita po yung atomic number sa periodic table. Kung ano po yung arrangement ng elements sa periodic table, based yan sa atomic number nila. So kung ito yung periodic table nyo, di ba, sabi ko requirement yung periodic table, every lecture natin, dapat may katabi kayong periodic table ha, or mag-browse kayo sa isang tab ng periodic table. Kung ito yung periodic table nyo, yung arrangement kasi, based sa atomic number, sabi ko kanina, kahit walang nakasulat na atomic number nila, kaya nyong ma-identify kung ano yung atomic number ng isang element kasi bilangin nyo lang, kung pang ilan yung element, yun yung atomic number niya. So, simulan nyo sa hydrogen. Hydrogen, di ba, nandito? Tapos helium, andito. So, 1, 2, then baba ni hydrogen. Yan yung number 3 na element. So, magbilang lang kayo. Kung pang ilan siya, sa bilang nyo, dyan sa periodic table, yan yung atomic number niya. Okay? So, again, yung isotopes ha, atoms of the same element with the same proton number, or ang ibig sabihin ng proton number, atomic number. But saan lang sila nag-differ? Basta isotopes. Different, sulat ko muna. Different neutron number. Ayan. So different na sila sa neutron. Small letter n, then 0. Small letter n to the power of 0 kasi pag neutron, 'di ba? Pag neutron, neutral. Wala siyang charge. Bakit yung kanina si proton may charge, ma'am? Di ba yung proton positively charged na particle ng atom? So take note natin ha, yung isotopes, same element, same yung proton number, but saan sila nag-differ? Sa number of neutron. Say for example, si hydrogen. Si hydrogen po, meron siyang tatlong existing na isotopes. Okay, sulat ko ha. Yung tatlong existing isotopes niya are the following. Okay? Una is si protium. Ang pangit ng sulat ko. Okay. Si protium. Pangalawa is si, okay, sulat ko muna ha. Si deuterium. Ayan. Then, yung pangatlo is si tritium. Okay. These are the isotopes of hydrogen. Ano nga ulit yung isotope? Same daw yung element. So, ibig sabihin, si protium, si deuterium, saka si tritium, same yung element nila. Ano yung element symbol ng element na hydrogen? Diba? Letter capital H. So, lahat sila the same. Okay? Kasi nga isotope, same yung element. So, hydrogen, hydrogen, hydrogen. Okay? And sabi, same daw yung proton number. Kung titingnan nyo sa periodic table, pang ilan si hydrogen? So, ano yung atomic number niya, di ba? 1, siya yung unang atom sa periodic table. So, itong table na to ha, yung second column natin, ito yung number of proton. Okay? Number of proton or atomic number. So, sa protium, 1. Paano naman si deuterium? Ganon din, 1 and 1. Kasi nga, yung isotopes, di ba, these are isotopes. Yung isotopes daw, same yung element. So, hydrogen, hydrogen, hydrogen. Same din yung proton number. Kasi, yan yung characteristic ng isang element. Hindi po paiba-iba yung atomic number ha ng isang element. Characteristic niya po yan. So, 1 yung atomic number ng lahat ng hydrogen. So, nag-differ lang yung isotope sa number of neutron. Ma'am, paano namin malalaman yung number of neutron? Okay. Yung number of neutron po, okay, malalaman nyo lang how, sige, sa talikod ta ha, kaya wala na space. Yung number of neutron, that is equivalent to the atomic mass. Capital A is the atomic mass. Yan po yung symbol talaga when you represent an atom with its atomic mass tsaka proton number. Yung capital A, ito yung atomic mass. Okay? Okay? Then, paano ulit makuha yung number of neutron? Difference. Hindi difference. Tama. Difference. Difference ng atomic mass tsaka yung proton number. Okay. Yung, hello? Okay, minus the proton number. Okay. Yung proton number naman na symbol to represent atom, okay, is capital Z. Okay, so ito yung atomic, ayan, atomic number or proton number. So, ito po yung way para makuha mo yung number of neutrons. I-minus mo lang. Okay, minus mo lang yung atomic mass, then yung proton number. Okay? Sige, try natin ha. Paano namin malalaman yung atomic mass, ma'am? Andyan po sa periodic table. Okay? Nandyan, naka-label po yan sa periodic table. Okay, dito sila nagkakaiba sa mass. Okay? Pag isotopes kasi, magkaiba ng yung mass nila. Hindi pwedeng parehas kasi pag parehas, edi same element yan sila lahat. Okay? Yung mass po ng protium, take note, yan po yung nasa periodic table nyo. Diba? 1 ang nandyan. So, yan po. Tama po to. 1 yung atomic mass ng protium na isotope ng hydrogen. Okay? So, check to. Ayan. Ano naman yung atomic mass ni deuterium? Okay? Yung deuterium po, 2 po yung atomic mass niya. Okay? Ayan. Then, ano naman yung mass ni tritium? Okay? Si tritium naman, 3 yung atomic mass niya. Okay? Basta isotopes, same yung element, same yung proton, same element, same proton. Nagkakaiba sila, di ba, sabi sa number of neutrons. Bakit nagkakaiba sila sa number of neutron? Kasi sa mass, magkaiba sila. Okay? 1 yung sa protium, mass ng deuterium is 2, 3 naman sa tritium. Ayan. So, paano ulit kunin yung neutron number? Tama po yun ha, minus. Okay, i-minus nyo lang. Okay, sige. So, again ha, paano makuha yung neutron number? Atomic mass minus the atomic number. So, i-minus lang natin. 2 minus 1, so this would be 1. Then 3 minus 1, this is 2. So, kung titingnan natin, basta isotopes talaga, given the sample ha, given this sample, basta isotopes, the same element. Ibig sabihin, the same symbol. The same yung proton number. Okay, 1, 1, 1. Then, they differ now sa neutron number. Bakit nag-differ sila sa neutron number? Kasi different yung masses ng mga elements sa isotopes. Okay, so pwede din natin sabihin different number of neutrons and different number of atomic mass. So, pwedeng ganun. Okay? Then, kung mag-search pa kayo ng marami pang isotopes, ganun din yung mangyayari. The same na element, the same proton number, nag-differ lang talaga sila sa number of mass or the neutron number. So, ayan ha. Sige. So, balikan natin yung, yung postulate ni John Dalton. Postulates ni John Dalton, yung proven statement na wrong or false statement na is yung first postulate kasi na hindi na natin i-consider na indivisible yung atom. Kasi nga meron na siyang subatomic particles. Then yung second postulate, sabi niya dito, all atoms of the same given element are identical. Hindi po. Hindi po sa lahat ng pagkakataon the same or identical lahat ng element of a given atom. Bakit? Because of the existence of isotopes. Okay? So, balikan ko ulit yung yung paano mag-represent ng element sa chemistry. Okay? Or paano mag-represent ng atom ng isang element. So, ganito ha. Capital X, ito yung representation natin sa element. So, ito yung element. Take note, capital X. Ma'am, saan namin ilalagay yung atomic mass? Yung atomic mass is written on the upper left corner of the element. So, di ba yung sabi ko kanina, yung capital A, that is the atomic mass or mass number. Nakikita po yung atomic mass sa periodic table, ha? Then, on the bottom left ng element, dito naman yung letter C. Ano yung capital letter Z? Di ba? This is the proton number or atomic number. Okay? So, example. Yung example tayo. Paano mo isusulat yung, erase ko ha. Paano natin isusulat yung sodium? Diba? Sodium, ano yung elemental symbol ni sodium? Diba? N, A. Okay? Ano yung dapat nandito? Atomic mass. Sige, tingnan nyo sa periodic table nyo. Ano yung atomic mass ni sodium? Diba? It is 23. I-round off nyo lang. Diba? It is 23. Ano yung proton number niya? Atomic number. Ibig sabihin ng atomic number, pang ilan siya sa periodic table na arrangement, di ba? Ika-11.
11.
Okay, very good. Ika-11 po siya. So, this is how will you represent, okay, the atom of sodium given its atomic mass, tsaka yung proton number niya or atomic number. Okay? So, yan lang. Okay, sige, proceed tayo. Okay, paano naman yung third postulate ni John Dalton? Sabi dito, atoms of different elements, they combine to form compound in a definite ratio of small whole numbers. Okay. Ito, okay pa siya. Okay? This is a very true statement talaga. Kasi 'di ba, when we form a compound, mag-combine ka lang ng different elements, different atoms of an element, then you have to express that in a definite ratio ng small whole numbers. Then, during chemical reaction, atoms daw are either combined, united, or rearranged, but they are never destroyed. Ito din, tama pa din yung statement na to. Kasi di ba during chemical, hindi naman talaga nag-iiba yung total mass ng compounds during chemical reaction. Nagre-rearrange lang sila. Okay? Or nagko-combine. Pero yung total mass na conserved pa rin sa chemical reaction. Okay? Sige, proceed na tayo. Proceed tayo sa laws or mga observations na inexplain ni John Dalton. So, ito yung mga observations ni John Dalton wherein na-formulate na siya into laws. I know familiar kayo dito sa law of conservation of mass, law of multiple proportion, law of constant composition. Okay? Sige. I-define natin yung law of conservation of mass. So, ibig sabihin dito, ito yung fourth postulate ni John Dalton, di ba? Sabi niya, during chemical reaction daw, yung total mass, okay, ng substances, it will never change. Kasi ang nangyayari lang sa atoms, they are rearranged lang or nagko-combine lang sila together. Okay? Hindi po talaga nade-destroy yung atoms during chemical reaction. Okay? So, yan yung law of conservation of mass. Na-conserve lang yung mass. Then, yung second law of, ito yung law of multiple proportions. Okay. Paki-take note, yung law of multiple proportion po, it states that two elements, again, law of multiple proportions, it states that two elements, okay, or two different elements, they can combine to form compound. Two different elements, they can combine to form compound in which one element in which one element can have different masses. Again, in which one element can have different masses expressed in small whole numbers. Yan yung multiple proportion. Okay? So, example tayo. Okay, example. Okay ha? Example, meron kang isang compound na CO2. Okay? Sa kabila, meron kang compound na CO. Okay? Kung titingnan natin, yung dalawang compound, okay, parehas lang yung present na element. Diba? The same lang yung element nila nga present. Yung dito, meron siyang carbon. Dito rin may carbon. Dito may oxygen. Dito meron ding oxygen. Saan lang sila nagkaiba? Sa isang element. Bakit? Yung isang element dito present in different mass. Wherein yung mass niya na-expressed in a small whole number. Dito 2, dito imaginary. Ibig sabihin ng imaginary, 1 po yan. Okay? So yan po yung law of multiple proportion. Meron kang 2 different elements. Pwede silang mag-combine, okay, to form a compound in which yung isang element dyan pwedeng mag-occur in different masses, which is expressed in small whole number. Yan yung multiple proportion. Okay? Then, the law of constant composition naman, constant yung composition. Ito yung sinabi ko kanina, yung under sa postulate ni John Dalton, yung pangatlo. Diba? Sabi dito, whatever the source of the compound is, kahit yung water nanggaling sa ibang bansa, water sa Philippines, fixed po always yung chemical formula ng water. Hindi po nag-iiba yung chemical formula ni water. Ganon din sa ibang substances, fixed po always. Constant yung composition. Ibig sabihin, definite yung proportion ng isang compound. Whatever the source of that compound. So, constant siya. Okay? Sige. Now, para mas maintindihan lalo yung laws na to, explained by John Dalton, let's try to have these illustrations. Okay. Which law do you think this picture illustrates? Okay. Analyze natin ha. Sabi dito, sa first illustration, second, tsaka third illustration, lahat sila may the same presence ng element, color ng element. Example, dito sa first illustration, di ba meron siyang color gold? Again, we're talking about the color. Color lang muna. Color gold na element. Siya din may color gold. Siya din merong color gold na element. Ganon din yung color green na element. Lahat sila may color green na element. Di ba? Itong first illustration, may green na element, may green, meron din siyang green na element. Okay? Saan lang sila nagkakaiba? Sa number of color green na element. Kasi dito sa first illustration, isa lang. Dito, dalawa na lang kulay green. Dito, tatlo na yung kulay green. So, bibigyan natin ng specific example yan. Say for example ha, i-specify natin yung example. Example yung, di ba tatlo yan? Iwi na siya, no? Okay. Wait muna ha. Ayan. Hiwi gyapon. Ayan. Sige. Say for example, yung kulay gold na element is sulfur. Lahat ba may gold element? Yes. 'Di ba? So example ha, yung kulay, example lang to, yung kulay gold na element dyan is sulfur. So lahat sila merong sulfur. Pasensya na sa sulat ko ha. Sige. Now, yung green na element, example, yung kulay green na element is oxygen. Lahat ba may kulay green? Yes. Sa first illustration, ilan yung oxygen? Example, yung color green ha, yung color green na element, oxygen, yung ilagay natin. Si illustration man, meron siyang ilan? Isa yung color green na element. So, isa yung oxygen. Ilan naman yung oxygen sa pangalawang illustration? Diba? Dalawa yung kulay green, so dalawa. Okay. Paano naman yung third illustration? Ilan na? Tatlo. So kung titingnan natin, lahat ng compound na to, lahat ng illustrated na compound, they contain the same element. Lahat may sulfur, lahat din may oxygen. Saan lang sila nag-differ? Sa number ng masses ng isang element, which is oxygen. Therefore, ano yung law na ini-explain or ini-illustrate sa pictures na to? Sige nga, sagot. Law
Law of multiple proportion.
Law of multiple proportion.
Okay, tama. Law of multiple proportion. So intindihin niyo lang ha yung statement ng law of multiple proportion. Sabi doon, two different elements pwedeng mag-combine to form a compound wherein yung isang element it can have different masses expressed in small whole numbers. So okay na tayo sa law of multiple proportion. Dito naman, which law does this picture illustrate? Sabi dito, yung hydrogen gas, okay, yung hydrogen gas nga 2.02 grams, gi-react sa oxygen gas nga 16 grams. Okay, now, recall natin ha, basta gani chemical reaction, before gani sa equals, before anang equals, kana imuhang i-combine before sa equals nga sign. This is what example A plus B, ito yung tinatawag natin na reactants. Okay, ito yung reactants, then yung after sa equals, ito naman yung products. Okay, so example A, B. Okay, reactants. Now, sa reactants na side, di ba, meron kang hydrogen gas tsaka oxygen gas dyan. Kung imong i-plus na 16 plus 2.02, di ba, that is 18.02. So, okay tayo sa reactants. Ano yung nangyari sa product? Nag-change ba yung may na-add ba, nakulang ba, hindi ba? Wala. Nag-form lang siya ng another compound pero na-conserve yung mass ng compound na ni-react. Okay? So therefore, ano yung law na in-illustrate dito sa picture na to?
Law of conservation of mass.
Or conservation of mass.
Okay, very good. So, di ba, madali lang siya i-analyze. Okay? Then, tapos na tayo sa law of conservation of mass. Okay. Ito naman, which law does this picture illustrate? Sabi dito, yung sulfur dioxide molecule is manufactured in a lab. Ito naman, sulfur dioxide molecule din, pero mined out from the ground. So, ito synthetically made. Ito, naturally na nakuha. Okay? Kinuha. Okay? Kasi na-mined out man siya. So, different yung sources nila. Pero kung titingnan natin yung illustration ng molecule, the same. So, ano yung law that explains this picture?
Law of constant composition.
Law of
Definite composition.
Okay, very good. Law of constant. Constant yung composition. Kahit saan pa galing yung compound na yan, basta yan yung compound, isa lang talaga, fix lang talaga yung composition niya. Okay? So, yun yung tatlong laws that has been observed na explain yan ni John Dalton. So, ngayon, na-form na siya into law. Okay? Anong oras na? Meron pang time. Okay? Sige. Ngayon naman, proceed tayo sa mga scientists na nag-contribute much sa advancements ng atomic theory. Sila naman yung nag-help discover sa mga subatomic particles. So again ha, because of the existence ng subatomic particles, hindi na natin i-consider nga indivisible yung atom. Okay? Sige. So these are the persons behind the discovery ng subatomic particles. So we have si Michael Faraday, siya yung nag-give ng clues on the electric nature of matter. Si William Crookes naman, siya yung nag-explain, nag-conduct ng experiment on the conduction of electricity through gases. And this is via the use of cathode rays. Okay? Then, siya yung discover ng cathode rays. Pero yung nag-explain further sa cathode rays, mga properties, facts about the cathode rays, si J.J. Thomson naman yun. I know familiar kayo sa mga names. Okay? Si J.J. Thomson, siya yung explain ng some of the properties, important properties ng cathode rays. And because of his study, i-continue niya ang study ni William Crookes, na-discover niya yung electrons. Okay? So, siya yung nag-discover ng electrons, si J.J. Thomson. Then, The one who discovered anode rays naman, si Eugene Goldstein. Sir Eugene Goldstein. Now, because of this discovery sa anode rays, na-discover naman yung positively charged na particle ng atom. Ano yung positively charged na particle ng atom? Diba? That is proton. Sino naman yung nag-discover ng proton? Si Ernest. Hindi siya nasama, no? Si Ernest. Okay, Ernest Rutherford. So, alam niyo na yung spelling ni Rutherford kasi kilala naman natin yan, di ba, sa junior high. Na-mention palagi si Ernest Rutherford. Okay, siya yung nag-discover ng positively charged particle ng atom, which is proton. And that is because of the discovery ng anode ray. Okay. Then we have Robert Millikan. Siya naman yung nakapag-determine sa magnitude ng electron charge. Then si James Chadwick. Okay, siya yung nag-discover ng neutron. Okay. Sige, iisa-isahin natin yung each of the scientists na nag-contribute sa discovery ng subatomic particles. Pero ipipinpoint lang natin yung pinakamahalagang bagay na na-discover nila na relation lang sa chemistry. Okay? So, unang-una si Michael Faraday. Okay? Si Michael Faraday, very known siya sa works when it comes to electrochemistry, electrolysis. Siya din yung nag-propose ng principle ng diamagnetism. Ginamit niya yung principle na yun para ma-discover yung electric nature ng matter. So, sa experiment niya, okay, ginamit niya yung electrodes. Familiar ba kayo sa electrodes? Okay, gumamit siya ng electrodes, gidip niya sa electrolytes. Okay, then dito niya na-prove na may electric nature talaga yung matter. Okay, so dalawang klaseng electrode yung ginamit niya. Yung positively charged, di ba? May positive charge. So ito yung positively charged electrodes. Okay? So ano nangyari nung dinip niya yung positively charged electrodes? Okay? Napagtanto niya na may mga particles na nagmamigrate on its end. Anong klaseng particles pala ang nagmamigrate sa positively charged na electrodes? Okay, opposite lang. Kung positive electrode yung ginamit niya, yung nagmamigrate is negative ions. Okay? Okay, ang tawag po dito sa electrode na to is cathode. Anode. Okay? Anode. Dalawang klase yung ginamit niya na electrode. Anode, tsaka cathode. Okay? Ayan. Ayan. Okay? Again ha, itong positively charged electrode, yan po si anode. Ma'am, bakit anode ang tawag? Di ba positive? Dapat cat, kasi cation. Hindi. Yung anode po, okay, describe siya, depende sa ions na nagmamigrate dito sa end part ng electrode. Now, since sa anode, yung nagmamigrate na mga particles is negative ions, tinawag siya na anode na electrode. Okay, anode kasi anions, okay, or negatively charged ions yung nagmamigrate dito sa end ng electrode ng anode. Okay? Then, yung isa, yung negatively charged naman, yung dinip niya yung negatively charged na electrode, yung nag-migrate na mga ions are positively charged ions. That is why ang tawag dito sa negatively charged na electrode is cathode. Again ha, negatively charged yung electrode, pero bakit cathode yung tawag? Kasi nga, positively charged ions ang nagmamigrate dito sa end ng electrode na to. Now, because of his experiment again ha, na-describe niya yung electric nature ng matter. So, yun lang kay Michael Faraday. Okay, punta naman tayo kay William Crookes. Hindi na-highlight yung ni William Crookes. Basta William Crookes to. William Crookes. Siya naman again yung nag-discover ng cathode ray. Yung lang, alamin nyo lang na siya yung nag-discover ng cathode ray. Wherein yung cathode ray, yan yung nag-help to discover the negatively charged particles ng atom. And sino yung nakapag-discover ng negatively charged particles ng atom? Siya po, si J.J. Thomson. Si Joseph John Thomson. Kasi siya yung nag-expand pa ng properties ng cathode ray. Doon niya nalaman, meron palang negatively charged particles yung atom. Okay? So, in his experiment, nakuha niya yung mechanical effect ng cathode ray tsaka yung heating effect ng cathode ray. Okay? So, ayan. Okay, balik tayo kay Michael Faraday. Si Michael Faraday, electric nature lang. Electric nature ng matter. Si J.J. Thomson, siya yung nakapag-discover ng electron with the help of the cathode ray. Sino yung nag-reconstruct, nag-discover ng cathode ray? Si William Crookes. Okay. Kinonform lang niya yung discovery ni William Crookes. Then, let's proceed to Robert Millikan. Si Robert Millikan naman, siya yung nag-determine ng magnitude ng electron charge. Okay? So, kung ano yung amount, magnitude ng electron charge, ito. So, ginamit niya experiment para ma-determine yung charge ng electron. No, not the charge. The magnitude of the charge ng electron is the oil drop experiment. So, ito yung ginamit niya. So, yung oil drop experiment, itong experiment na to, it follows physics. So, that is already beyond the chemistry discussion. Basta alamin niyo lang na si Millikan, si Robert Millikan, siya yung nakapag-discover ng, siya nang nakapag-determine. Okay? Na-determine niya talaga yung magnitude ng electron charge using the oil drop experiment. Okay? Ayan. Then si Eugene Goldstein. Si Eugene Goldstein, siya yung nag-discover ng anode ray. Opposite, sino yung cathode ray? Sa cathode ray, di ba si William Crookes. Because of that cathode ray, na-discover yung electron. Now, yung anode ray na na-discover ni Eugene Goldstein, ito yung dahilan, because of this discovery, na-discover yung positive naman, yung positively charged particles ng atom. And sino yung nakapag-discover ng positively charged particles ng atom? Si Ernest Rutherford. Yung proton proton yung positively charged particle. Okay, then si James Chadwick, siya naman yung nag-discover ng neutron. Okay, neutron. James Chadwick. So, hindi na natin aaralin kung paano nila ginawa kasi hindi natin yan magagamit sa pharmaceutical chemistry 1. Okay? Basta alam niyo lang yung persons behind the discovery ng subatomic particles kasi importante yun si electron, proton, neutron. Okay? So, again kung ito yung atom mo, yung nasa inside po ng atom, andito po yung proton, tsaka neutron. So, dito yung nucleus. Nasa nucleus po, nasa inside ng atom yung proton tsaka neutron. The reason bakit positively charged yung nucleus, that is because of the influence ng charge ni proton. Okay, again, the reason bakit positively charged yung nucleus. Yung nucleus hindi yung neutron. Bakit positively charged yung nucleus? Because of the influence ng protons charge. Ayan. Then, yung nasa labas naman, okay, very far away sa nucleus, andun makikita yung mga electrons. So, those are the subatomic particles ng atom. Ayan. Okay. May time pa. Okay, may 6 minutes pa. Sige, proceed tayo. Proceed naman tayo sa mga atomic models, yung special nga mga atomic models that helps describe atoms. Okay? So, J.J. Thomson ulit. So, J.J. Thomson, siya po yung nag-relate ng atom sa isang raisin bread model. Okay? Or siya yung nag-propose ng plum pudding model. So, according sa kanya, using this model, atom daw is a sphere, consists of positive particles to which negative particles are embedded. Parang ganito. Para daw raisin, parang cookies. Nakakita naman kayo ng cookies, di ba? Di ba yung cookies may mga bilog-bilog? Example, meron siyang raisin. Okay. Yung mga raisin daw, andun daw yung negative. Embedded daw doon yung negative charge. Okay? Sabi niya, negative particles are embedded. Then, sa labas daw yung mga positive charge. Yun yung sabi yun yung para sa kanya ni J.J. Thomson. Pero, dinisprove ni Ernest Rutherford yung model ni J.J. Thomson. Para kay Ernest Rutherford, using the gold foil method or nuclear method, okay, he was able to determine na yung atom daw, yung atom mostly empty space talaga siya. Okay? Empty space daw siya with a small dense na positively charged center. Bakit positively charged yung center? Di ba yan yung nucleus? That is again because of the influence ng charge ng proton. Okay? Then yung electrons daw nasa pinakamalayo. Malayo siya sa nucleus. Okay? So at a large relative distance to the nuclear part. Okay? Yan po yung kay Ernest Rutherford. Okay? Sige. Which is, yun yung tama actually, si Ernest Rutherford. Sige, proceed tayo sa planetary model. Almost the same lang actually. Yung explanation ni Ernest Rutherford tsaka ni Niels Bohr. Kasi kay Niels Bohr, yung planetary model naman sa kanya. In-explain niya na yung electrons, they move around the nucleus in a circular orbit. So, ganun pa rin. Yung electrons, nasa labas talaga siya ng nucleus, moving around in a circular orbit. Yun yung kay Niels Bohr, yung planetary model. Then, ito yung next topic natin, yung quantum numbers. So, yung quantum mechanical model naman, pinopose naman to ni Erwin Schrödinger. Okay? Sabi niya, yung electrons naman, they move in three-dimensional space called electron cloud. So, ito yung next topic natin, yung quantum numbers. Pero it takes an hour para malaman natin yung apat na importanteng quantum numbers. Okay, so next meeting na lang yung quantum numbers. Okay. Sige. Then, again ha, i-introduce ko ulit yung paano mag-represent ng atom given its atomic mass tsaka yung atomic number ng element. Yung atomic mass, this is the capital A. So, written siya on the upper left corner ng element. Okay. Then, yung atomic number nasa bottom left side ng element. Okay. Paano ulit makuha yung atomic number? Nasa periodic table. Kahit hindi nakalagay dyan ng atomic number, kayang-kaya mong makuha, malaman kung ano yung atomic number ng element. Bilangin mo lang. Mula kay hydrogen, papuntang helium, balik ulit. Okay. Balik ulit sa left, then going to the right. So, ana lang magkuha og atomic number. Okay. So, paano kunin ulit yung mass number naman? Yung mass number naman, this is equivalent to the number of protons and neutrons. So, pabaliktad lang. Okay, di ba kanina, yung na-introduce ko kanina is how to determine the number of neutrons. Di ba yung neutrons, atomic mass, minus the atomic number. So, yung mass naman, ito, mass naman, paano kunin to? Yung mass, i-transpose mo lang. Okay? So, ibig sabihin, transpose mo. So, atomic mass will be equal to, okay, neutron number plus the number of proton. Yung capital Z ha, this is the number of proton or atomic number. Okay? So, ayan. Okay, tapos na tayo sa fundamentals ng atomic theory.